All right, thank you, everybody. We're going to go on to a panel discussion now. Our topic is optimizing cloud cost and performance with autonomous cloud. I've got a very impressive panel here joining me, Smesh, Kumar, John, and Benji. I'm going to give a little bit of an introduction just on how the field of cloud cost management has evolved over time, and then I'll be giving a little bit more of an introduction for each of the panelists and asking them a couple of questions. So a couple of the key trends here, and if we could bring up on the monitor, if possible, our slide on the evolution of cloud cost management in a few seconds, that would be great. So cloud cost and performance, obviously a super critical topic, particularly as the industry has moved onto the public cloud in particular, which brought a whole new series of challenges relative to managing utilization in data centers. We've really seen a shift, as a bit of a backdrop here to the talk, a shift in the focus of the types of cloud cost management tactics that are available, and really an increase in the sophistication. A couple of the generations that we've gone through in terms of cloud cost management. The first was really, we could call it governance, which would be things like just basic usage tagging, being able to allocate costs, manage discounts that you're getting from your public cloud provider. The next generation really is monitoring. So tactics like cost dashboards, cost forecasting, uncovering anomalies, turning off virtual machines or instances that developers have sort of left on, forgotten to turn off. I think many folks have probably heard the stories of startups that sort of went out of business because someone forgot to turn off some setting on AWS. And then, one of the more recent generations of tools, really, I'd call them like point optimization tactics. So things like managing spot instances, reserve instances, picking the right type of instance, using auto scaling effectively. We could call these kind of rules-based approaches. And then I think where we're sort of going for the future, I think, and this I think ties to the topic of the conference today, which is really autonomous. So autonomous optimization tactics for costs would include for example, being able to really understand, like, is latency or cost most critical in your application, and optimizing based on that particular objective. So we just heard from Prakash at Fabric before. He mentioned a key element of his ROI is really performance and so on, because that drives revenue for his customers. So really having the right mix of performance and cost is very critical. Getting more sophisticated using AI ML to sort of predict the amount of capacity that's going to be needed, not just looking at the historical trends. And also looking at, from a release intelligence perspective, what is really the behavior of each release as it comes through. Everyone's trying to release faster these days and learning quickly if the new release is performing as it should. In terms of performance and cost is critical as well, are a few of the backdrop trends here. So that's a little start for our conversation today. I'm going to now introduce some of our panelists and ask some individual questions first. So first, I wanted to introduce Smesh. Smesh is the Senior Director leading platform engineering at PayPal. Very huge scope of responsibility for really the infrastructure and application platforms for the entire PayPal ecosystem. So over 400,000 VMs and 5 million containers. So certainly the need for automation it certainly would make sense in that environment. So Smesh, if I could ask you a first question. How do you manage cloud scaling for the best customer experience? So managing both cost and performance, really, especially given when you've got so much seasonality at PayPal.
Hey, good to see you all, guys. So PayPal generally follows the typical internet pattern, the traffic pattern, Monday peaks, immediately followed by Sunday peaks. And both those days, we see a pretty heavy traffic from 3 a.m. to around 3 p.m. And we peak around like 11 a.m. in the morning. Then after 3 p.m., as the sales in the e-commerce generally comes down, we can really reduce the size of the site. So earlier, to support the business, we used to fix size the site, and basically based on a seasonality like the holiday period in November, Black Friday, and Cyber Monday, around that time. But over a period of time, we moved into deep ML-based technologies to predict the sizing every 3 hours and readjust the site into every half an hour. So the containers will go from the 5 million we talked about. It will be there from the morning, say 3 a.m. to 3 p.m. But in the evenings, it will come down to 1.5 million.
Wow.
Then it will come back again at 5 million in the morning. So with that, we are able to save around 60% of the compute sizing. And that's just one piece, right? And every day the capacitization in the site changes. That's all possible based on the automations which you develop based on the ML. Looking at latency, CPU, memory, all the aspects of the site. So this enabled for us to focus really on the application rather than the infrastructure. So earlier we were spending a lot of time in sizing the site based on infrastructure. Now the focus shifted into how we can make the applications better because this is fully automated at a scale level.
Yep.
So it resulted in almost like 60% efficiency gains, which translate into multi-million dollars for PayPal. Reduced the size so that the complexity of managing it across also reduced a lot.
Yep.
It helps the business to drive faster.
Yep. Yeah, 60%. That's pretty impressive. Yeah. A follow-on question for you. We've just been talking about the scale that PayPal's operating at, and your environment spans basically on-prem and public clouds. How are you seeing AI and autonomous systems helping you with managing, that really complex multi-cloud environment, including Kubernetes and other platforms that you're running across those environments?
Yeah, so we run a very complex site. Plus, we also have close to around 10 adjacencies, business units like Braintree, Zoom, Honey, Jetlore, multiple pieces interacting with the PayPal site, which is each of them are, you can think about 2 to 4 billion revenue in a year, right? But plus PayPal site is having close to around 20 billion revenue in a year. So each of those micro sites plus the PayPal core site is consisting of around 4,000 plus stateless services. And you can think about 200 plus stateful services, including Kafka's databases, hotels, and everybody, all those pieces. So think about if you're trying to do the manual operations in this 4,000 plus microservices across the BUs and PayPal core, plus the stateful service management in a manual way. Just to give a context, we have close to around 200 million plus changes in the site in a year. So think about those changes, how it is going to impact the site and production issues. Triaging the issues coming out of that in a manual way would have been really difficult for us. So we automated the entire process of rolling out the changes based on the predictive analysis, looking at the issues from a triage perspective, getting it faster, giving that visibility into our SR engineers in a faster way. Definitely helped. You can think about PayPal had close to around 250 SRE engineers. We were able to reduce it at least by 1/6 of the size based on the automations which we developed, which enabled us to reinvest those headcounts into areas where we really needed, like more application fine-tuning, performance fine-tuning, and other things, than focusing on the infrastructure. So I would call that optimizations which we have done more resulted in effectively using the headcount in the right way for the company. That's what I would call as one of the biggest.
Got it. Yeah, you're reminding me of one of the themes from earlier in conference about kind of shifting up and being able to focus on the application, some of the high level issues. Yeah, thank you. Next, I wanted to introduce Kumar. Kumar is the CTO of TopCoder, which is basically one of the largest developer cloud sourcing companies. He's also ex-eBay and PayPal, like some of the folks in the room here. And actually has multiple patents in cloud and distributed computing. He built one of the earliest private cloud platforms. This is pre even AWS and Azure being available, and basically was a PaaS service. So Kumar, I had a couple of questions for you.
Sure.
Thank you very much for joining us.
Thank you.
First, we know that you're a strong advocate for autonomous systems and probably one of the first to go all in really at eBay. with the PaaS platform that we mentioned, which is running on OpenStack. Why would you look at autonomous systems when you have a lot of different individual pieces of automation already? And could you talk specifically about cloud costs and team efficiencies around this as well, please?
Sure, yeah. Automation itself is not new, right? I mean, people have been doing this thing for a while. And in fact, on eBay, we had a lot of point automations. So we would actually look at, like, say, server, and then see if server is running over certain memory capacity, then we'll just nuke that. We also had, like, some checks on, like, number of connections the server would have. Now, all those things were good, right? So, but then, over a period of time, we found that specifically doing all those automations was actually causing more problem than it was actually helping us. Specifically, look at this one. I would say that there are three problems, right? The first one would be, like, most times when people write automation, they code for extreme situations. They assume something is going to happen, right? They don't know exactly what's going to happen. The data is based on the past performance rather than what's going to happen later. So when you code something like that, you pretty soon you realize that that's going to be invalid after a while, right? Because you have a lot of changes happening in the site. People do code rollouts, and you don't necessarily look for seasonality, or you don't necessarily adapt to some of the changes that happens. So when that happens, your automation actually sometimes is going to work against you rather than help you, because you assume certain things that happened in the past, and you think that will happen in the future, but things change. So that's one big problem we saw, that like, automation itself is not bad, but it wasn't helping as you have a lot more velocity in terms of rollouts. And then the second problem we found was, when you look at automation, right, it was actually mostly for helping SREs, right? It helped them manage their infrastructure better. But what we really care about for a business is the applications, how the application behaves. You could possibly actually have a infra that's not necessarily optimal, but if the application looks super good, it's okay. The other way around, if you have, like, optimal infrastructure, and if your application is failing left and right, it's not going to help you. So the SREs were coding for the application health, the infrastructure health, but without actually knowing about the application itself. As one big problem, right? So we actually looked at this thing and said that, what can we do so that the application folks can have a say in automation, right? And so the idea here is that you start coding against some of these, the behavior of the application, and then react to that thing, and then you actually have, like, the application folks be able to plug in their logic into this, right? So that was something. Second point, I would say. And the third one, if you see, is that these applications are getting more and more complex, right? What used to be, like, few rollouts changed to, like, hundreds of rollouts. You have, like, developers rolling out left and right. So they can roll out anytime. And so we found that we were writing automations for specific flows, and we were adding more and more automation, which is not a bad thing by itself. But then, in spite of all those, the SRE's time spent on this thing wasn't reducing, right? So you had a situation where, like, more automations are happening. In spite of that, you need more SREs, right? So that's possible because, like, what's happening here is that the SREs are sort of, like, decoupled from the application owners itself. They don't know what's happening in the application. So the solution for all those things is actually, like, not necessarily, focus more on automation, but rather look at autonomous systems, right? So when we did this thing, that's what we realized that, eBay too, we built this autonomous system that was actually looking at the signals from the applications, right, along with the signals from the infrastructure, and then be able to make some intelligent decisions on that, right? So I would say, like, when we actually, like, moved from automation to autonomous system, it was more around, like, how things were evolving fast. So in order for us to keep up with that, we can't be just adding more and more automation. It has to be, like, more autonomous system, right? So that's in short about, like, why we focused on autonomous system in eBay.
Got it. And as a specific follow-up on that, one of the other changes in the industry as well has been, the growth of Kubernetes, as you might call it, a declarative orchestration platform. How are you thinking kind of autonomous systems and declarative systems like Kubernetes work well together? Do you think they're kind of complementary, or do they compete in some way?
Yeah, that's a great question, right? Because everybody thinks that, well, we have Kubernetes, right? You have Mesos. In fact, we started with Mesos before. Like, why not? Why do you add one more system, right? The thing here is that you got to see, these are, like, solving two different problems. right? Kubernetes, Mesos, this cluster manager is specifically focused on managing your cluster. And they do an awesome job in terms of actually figuring out like what your infrastructure is, how do you manage infrastructure, what's your target state, and then constantly moving towards the target state, right? We used to have like something like in eBay where WSB versus wiry, right? You define what the state is, and then constantly you're working towards getting to that state. That's all fine if it's all about infrastructure, right? But all these guys think what's running in that instance is a black box. They don't know what's happening there. You could, as I say, I think like we've seen this in the past where like we would just constantly go and then like nuke the box, bring it back, but still application wouldn't perform the way you want, right? There's something else that's happening, or probably you're not looking at the proper signals. So that's why I think while Kubernetes and Mesos, they're good, right, and they're very much needed because you have more microservices, more of these clusters that's happening. They can just solve the problem with themselves. And for the new world where you have like bunch of applications, complex logic that's going in, you got to have new solution, right? So that's why I believe autonomous managing this thing, complementing Kubernetes with this autonomous system is definitely going to be good. And you really have to like see all these application signals. And I would say that even in TopCoder, we don't have a scale that Sumesh was talking about in PayPal, right? We don't have that.
Yep.
But even in spite of that, right, we have like only one SRE person, right, managing entirely all this. I don't think like even if you actually have a proper autonomous system, even that that DevOps person or SRE person is not required, right? As long as we know exactly how the applications behave and what's expected behavior of the applications, you kind of like leave all this infrastructure. That's not a problem anymore right now, right? We've seen that a lot of systems. I think the problem is actually surfaced up a little bit, right? You're gonna hit there, and as more and more folks start using microservices, complex business logic, use more and more of a Kubernetes, I believe that the autonomous management system is going to be more relevant. Right? So, in short, they're not, they're complementary.
Yep.
They're not like conflicting or actually competing.
Yep, got it. All right, thanks. Thank you, Kumar. Yeah.
Thank you.
So nuking the box is a new technical term. I just
Dean would know about that.
From now. So. All right. Okay. Next, want to introduce John Fiedler. Thanks for joining us, John. John is the CISO and head of platform engineering at Ironclad, which basically is a leader in digital contracts. And John was previously the VP of engineering at Salesforce, heading up Einstein infrastructure, which was Salesforce's major push towards AI. For those who don't know. So welcome, John. Have a couple of questions for you here. With your background in building Einstein at Salesforce, an AI platform, how do you see AI and autonomous systems helping you build complex cloud platforms such as Kubernetes or and also private clouds built by platform teams?
Thank you for the invite. So I think the Einstein journey at Salesforce was really an interesting one. And to the other panelists' point is a lot of autonomous and automated systems really rely on the application above, right? We've been successful over I'd say the last decade of automating a lot of infrastructure with the advent of virtualization that really changed the game in performance and utilizing the underneath hardware. And then came the programmatic data center, which we had cloud, right? That's what everyone calls cloud. I just call it programmatic data center. Everything had an API. So then came, I'd say, AI and ML, and there was many startups that Salesforce essentially acquired that built out Einstein. And one of the things I think when we first launched is you saw some of the great teams who had really cost-effective solutions, and they always were around auto-scaling. There's who was using EMR or Spark and having configured, auto scaling where, in the morning or when a job came in, it would scale up and scale down, and it would be able to predict some of that data. And we even started with, let's say 10,000 predictions. And by the time I left, we were doing over, billions of predictions every single day. But really at that point though, we were only able to make the cost-effective pieces the underlying infrastructure on AWS, and that was it. There's actually many layers above that we couldn't still touch and unlock. Many of those were the models themselves, hyperparameter tuning of every single one of these models, and nowadays they're very sophisticated, and they have, let's say hundreds, even thousands. I heard somebody said the other day a model was trained on billions of parameters. There's no way a human can go through and actually adjust every single one of these for the efficiencies that we're trying to gain. And so we can get SaaS, I'd say SaaS applications today to a really good spot of, let's say, 20% margins. That's, I'd say, the minimum bar these days. We've had teams at Salesforce running close to my own at 10%. That's 90% back to the business, which is absolutely phenomenal. There's only one way that we can continue reducing that, and that's more automation, but autonomous systems. Because it's gotten so complex, there's too many layers above to throw more, I'd say, manpower at the problem. And so we're looking towards autonomous systems. We really learn from Einstein what's possible and what's not possible to make the applications above really more cost effective because of the complexity, because of the layers, and because of how many options now are adjustable within these applications, models, and the underlying infrastructure in the end of the day.
Mm-hmm. Yeah, that's pretty advanced system here, particularly the billions of predictions is pretty incredible. Yeah, so I think it's really beyond human scale. I have a follow-up question for you, and this is recognizing that you own security in your role today at Ironclad. So the question here, some of the things that are at the core of what you do at Ironclad, the company describes as sort of trust, integrity, speed. Some of the things that are at the core. What would be your advice on things to watch out for, including kind of from a security perspective, when you're implementing an AI-enabled platform on a production cloud?
Yeah, I think there's a couple things to watch out for. And I think the other panelists, don't be afraid of autonomous systems. I know a lot of people, they kind of go one way or the other. I think it's really complementary. Use it as a tool. It's there for your advantage to continue investing in the innovation of you and your company's systems to make it more efficient in the end of the day. From a security standpoint, we're overloaded. There's not enough people. Still security industry is, starving for resources. I'd even say, former SRE teams, operations teams, platform teams, still there's not enough people to go around. I also am responsible for IT, and I see many organizations, 500 to 1,000 people, have over 500 SaaS applications. It's not slowing down, it's speeding up. There's not enough almost people to go around. And in security, we have to, if see something, say something. If it moves, you should be able to monitor that. I need to know the entire surface area of the business at all times. And that's very, very hard without autonomous systems or automated systems these days. And so traditionally, you hire a NOC or a SOC. Those days are gone. Now you have these monitoring systems, that have monitoring plus logging built in, metrics versus log aggregation. And that's great. And that's got us to a certain point. And it's no longer competing, I'd say, in the market now. It's that there's so much data and so many systems and so many integrations and so many new SaaS applications coming on board that it's just almost overwhelming that we need to have these autonomous systems brought in. And so looking at the next gen systems is almost critical for us to keep up with the new advances in security. We've gotten to the point where we've gotten newer technology in that we're no longer considering teams like security, such as and platform and even data engineering as cost centers anymore. Mm-hmm. We actually think they're customer driven value proposition or feature development teams. I get on calls with customers and they say, "Hey, I want to bring your own key. How can we enable that? We want data centers in a new region. Can you do this?" Yes. It used to be, we'll do that in 5 years. Now now it's we have that next month. So it's, now we've kind of turned it from being a cost center, and now we're a value proposition to the customers. Now we're at the seat of the table with also the revenue team. We're trying to predict, how much sales we're going to have for the next quarter and next year. And it's really interesting to have platform and the security team part of that conversation now. Before they used to be thought of as cost centers. And I really love that. Now that we're here in this part of the industry, no longer being thought that way. So that's what I had to share.
Yeah, that's really interesting. I think also the the cost versus profit center point. I think we've seen some examples of that in other parts of the day as well, where based on the tuning the amount of cloud cost investment can actually help drive revenue, for example, as well. So fascinating, John. Yeah, thank you. And then I want to bring us to our last panelist, Benji. Benji's the co-founder and COO at Sedai. He's led multiple autonomous platform initiatives at internet scale companies prior to joining Sedai, and he's kind of working on the problem, I think, a little bit that John mentioned of, there's just it's could be very easy for teams to be overwhelmed today, given just the growth and complexity of the system. So he's basically working on that problem. So Benji, welcome, and have a couple of questions for you. So. The first one was really around Kubernetes, Benji. So Kubernetes we were discussing earlier was kind of a declarative platform. Has a lot of automation, HPA, VPA, kind of examples that we covered earlier today. If that's the case, what is the need for an autonomous system? Can't a company just manage its fleet with the automation capabilities in Kubernetes already? And do you have any thoughts here and numbers that could provide some perspective?
Okay, I'll throw one data point and then I'll answer the question. So I was looking in LinkedIn yesterday. There are 450,000 professionals with Kubernetes skills around the world. 85,000 jobs open. Okay, so obviously it's not fully autonomous, right? You need to manage Kubernetes. So if it was a magic bullet that solved all the problems, you wouldn't need so many people to manage Kubernetes clouds. So that's one data point right there. But there are a few things that K8 does beautifully, right? Orchestration of the cluster. So you give n nodes, Kubernetes will manage the cluster. It will pack the pods in the right configuration. Bin packing is a close to NP hard problem. They have solved very close to it. What Kubernetes doesn't solve is awareness of what the application is, how the application behaves. And Sumesh, you mentioned seasonality in PayPal, right? It changes every day, it changes every week, it has annual seasonality. So what Kubernetes provides for such scenarios is tools for engineers, right? So HP and VPA are tools. So effectively, per application, you need to go and write the configuration. Hey, this is my horizontal pod autoscaler for my wallet application or my item pickup application. And okay, you need to look at CPU, you need to look at memory, you need to look at open files. These are the thresholds. Okay, now you horizontally autoscale your pods. So somebody needs to write rules. Okay, and the moment you put in a static rule, a week later it's outdated because your company seasonality, you have an acquisition, it changes. Your microservices sometimes get clubbed into one. 5 of them can become one. One can become 5. So organizations have this very highly dynamic seasonality, microservices, they're being pushed all the time. It's hard to manage configurations for 100 applications, forget about 4,000 applications, right? So that is where Kubernetes becomes complex. At the end of the day, it's the SREs or the application team's job to manage Kubernetes, right? So you need to write the configurations. You need to, code for seasonality. Okay, it's not impossible. You could do it. You could throw 50 performance engineers and SREs and engineers at it and say, hey, go right. Okay, this team focuses on merchant applications. This team focuses on warehouse management applications. Now, their job is to write these configurations. So that's when Kubernetes becomes hard. And that is the reason why, public cloud providers like Amazon comes up with serverless, cloud native features, because cloud is going to handle that, most of the challenges. And that is where autonomous is very effective, right? Who is going to figure out these configurations when applications change behavior? right? And who's going to figure out seasonality? Who's going to predict for the changes that are coming up? So that's where I see autonomous kind of adding value. And then the question that you asked, John, right? And what are the side effects, right? If you write point automation, are you doing all the safety checks? And is your safety checks changing over time, right? Are you doing your pool depletions right? Are you draining traffic right? And those things also change. That's where you need closed loop systems which learn and optimize over time. So that's where autonomous systems are valuable. Yeah, K8's beautiful. It manages clusters very well. It manages pod scheduling very well. It doesn't know. It's not app aware. It doesn't understand the dependencies between apps. It doesn't understand seasonality. So it cannot write configuration, but they can give an option to write configuration. So I think I think you asked that question to Kumar, right? It's complementary at the end of the day. So the declarative platforms, Kubernetes is one such. They have a lot of configuration options on top of the platforms, right? But who's going to use it? You need autonomous systems to intelligently configure those. That's where I see the value.
Yep. Yeah, and as a follow-up really on the value, we were discussing kind of hard ROI kind of earlier in the day. To put you on the spot here, I mean, what do you think is the difference, in cost and performance between, say, a semi-automated application and an application that's 100% autonomous, and what are the levers that you can really pull?
Okay. Yeah. So again, in semi-automated systems, you could save costs, right? You could write intelligent knobs. I'm not saying it's impossible to write, but you want someone to maintain that semi-automation, right? So Fabric as an example, right? Headless e-commerce is the business. It's a e-commerce company. Their focus should not be on cloud. So Prakash talked about innovations they are doing, right? Do they want to be, be a Kubernetes, build the Kubernetes expertise or build serverless expertise to write these knobs, these semi-automation points, right? So I think that's where, where does companies want to invest, right? Do they want to invest in their own business or do they want to invest in cloud as a business? So that's where that difference comes in. Okay, they may want to automate a lot of things in their domain. They probably don't want to invest in cloud as such, right? So that's my perspective on that second question. The first question in terms of cost, you mentioned multiple levers, right? So there is the whole governance piece. Then there is optimizing costs in app, optimizing costs at the cluster or your node level, then optimizing cost at the purchasing options. Each cloud provider gives you a number of purchasing options, right? And they all change all the time. Amazon is bringing out new flavors every week. Somebody needs to keep track of those. Amazon is bringing up new node flavors every week. There's GPU specialized, there's CPU intensive, memory intensive. So who's going to build the expertise and write semi-automation for all those things? If your business is in e-commerce, you would probably want to focus on that. So that's where I see, who writes that automation is where I see the difference. In terms of data points, to your question, what I've seen is even on top of semi-automation, especially in places that we are deployed, we see another 50% in terms of app optimization as well as purchasing and node optimization happening. Because usually when we write semi-automation, everybody wants to be safe. So even if my prediction is to have 120 nodes, I'm going to put 180 nodes just to be safe. I don't want to be on the hot desk when traffic spikes and the error rate spikes. So yeah, to your question, I still see cost benefit on top of semi-automation. Yeah.
Great. Thank you, Benji. Great. So yeah, I wanted to thank all our panelists, Sumesh, Kumar, John, Benji. Thank you very much. I know you're all companies represented really on the forefront of autonomous, which is our top focus today. So really appreciate you guys taking the time and coming down and joining us today. So thank you very much.
Thank you, John. Yep. Thanks.